Hello everyone, welcome to a presentation on improving the query pipeline for part 2 of the Quicksilver project. Tim and I will give you a short presentation about our strategy or implementation plan and our progress so far, and we are presenting on behalf of Group 9. In this video we will talk you about our strategy. This is called SCOOFY and it stands for Smart, Quick and Frugal. Then we are going to explain our implementation plan. This will be a step-by-step plan for building our pipeline. Then we are going to discuss our current implementation, what we have designed so far, our current results, and finally how we are going to improve the implementation.
Moving on to our Squiffy strategy. The first section of this strategy is the Smart section. Herein we will be splitting our queries into two different categories. The first will be traversal queries, where there is either a source or a target node, and the rest will be graph queries. For our traversal queries, we will be using the CSR representation of the graph, as this offers much faster lookup times. We will also be using a bidirectional breadth-first search to compute them. This breadth-first search can also implement hashes so that we can multi-thread this search. For the graph queries, which we consider the biggest challenge for a quick execution, we will have to generate query plans. We will, to generate all the possible query plans would be n to the -1 factorial, which is unfeasible. So we use a permutation seed to reduce the amount we actually have to calculate, and a k-1 technique that we found in a paper. This will cause us to only have to generate 2 to the power n-2 query plans in total, which is a great reduction. We will also be using dynamic intermediate graphs for the graph joins in this section, as constantly rebuilding our CSR graph is unfeasible. We will also try and multi-thread as much of our graph query process as possible. We'll then be moving on to the quick section of our strategy. To speed up our traversal queries, we'll be using a CSR representation of the graph, which offers significantly faster lookup times. We'll also be using dynamic intermediate graphs for our graph joins, as this will be a lot faster than constantly having to rebuild our CSR graph. We will also be trying to implement as much multi-threading as possible, as there are 24 logical cores available, which will significantly speed up the entire process. We then move on to the frugal section. Here the focus is to minimize our memory usage. We will be using a CSR representation for our traversal queries, which is then a static main graph. This is a lot more memory efficient, as it avoids storing empty entries if the graph is relatively sparse, so this will take up a lot less space. We'll also be using hashes as much as possible in our graph joins, as this also takes up less memory.
So now I'm going to discuss our step-by-step implementation plan. So our first task is the need to determine the query type that we're going to evaluate. We are going to categorize the queries into two different types. So we have traversal queries or we have clean start queries. And the traversal queries are queries that start from a node to any node or from any node to a node, while the clean start queries can start from any node to any node, and these are usually more complex. So for our second step, we need to decide on the graph storage format based on the query type. For static graphs or graphs that don't change over time, we can use the CSR format, and this is efficient for traversal queries because CSR allows us to store the graph compactly and we can access the edges efficiently. And then for the dynamic graphs, these are the graphs where the nodes and edges can change over time. So we use intermediate graphs for it, and we are also going to use hash maps. This strategy is usually for handling the clean start queries. For our third step, we have now determined the query type and we have determined a storage method, and now we're going to proceed to the query execution. So for traversal queries, we use the bidirectional breadth-first search, and this allows us to explore the graph from both the source and target nodes simultaneously. For the clean start queries, it's a bit more complex, so we're going to generate multiple query plans and evaluate each one on its efficiency. And finally, we're going to select the most efficient plan and method, depending on different factors. And then for the fourth step is parallel processing. We want to further optimize the performance, and we can use multi-threading to speed up the query evaluation. By executing parts of the query in parallel, we can reduce the time it takes to evaluate a query. So now I'm going to discuss our current design and implementation that we have already done. So first we did the query parsing. That is when a query is received, we parse it and determine its structure and its type. Here the goal is to identify the type of query, so whether it is a traversal query or a clean start query. And then for storing the graph, we use CSR formats for the static graphs. And for the traversal queries, we have implemented a bidirectional breadth-first search strategy. Then for the clean start queries, it's a bit complex, but we are going to use graph joins to combine the results from the multiple traversals, and we evaluate the cycles. And for the clean start queries, we need to generate different query plans. And finally, we have implemented a template for multi-threading to speed up the query evaluation.
Then for our results, we only have the CSR graph and breadth first search properly implemented at the moment and able to run on the server. And this is the result we had from running it on the server.
And finally, now I'm going to tell you how we're going to improve the implementations. So the biggest part is to implement or template multi-threading. We can use this for the breadth first search reversal queries using hashes. We can use it for the graph joins, for the query plans and selections. And another improvement is to make graph joins faster. And here we can use different methods depending on the query and the graph. And this was our presentation.